Alright guys, so in this problem, we have two natural log functions being graphed, okay? So in red, we have our parent function, okay, ln of x. And in green, we have the transformation that took place. So before we describe the transformation, let's first describe a couple things on this graph. Okay, first, for our parent function, or f of x, we're going to have a vertical asymptote in respect, all right, to this vertical axis. So at x equals 0, we're going to have a vertical asymptote, okay? And so my marker is dying here. Might have to do this in another color. So at x equals 0, we have a vertical asymptote. Okay, so as this function extends down to negative infinity, it gets closer and closer to 0, but it doesn't actually touch it. Okay, likewise over here, we're going to have a vertical asymptote at 4. Okay, so at 4. So again, as this function extends upwards to positive infinity, it gets closer and closer to 4, but it doesn't actually touch it. And you may be asking yourself, well, how do you know where these vertical and these horizontal asymptotes are occurring? Well, there's a couple ways you can do it. All right? If you were to plug this into your calculator right now, so if you plug in ln of x and we replace the x with 0, so if I do natural log or ln of 0, you're going to get an answer on your calculator here that says error domain, meaning it's not part of the domain. Okay, and we know why this occurs, because think about it. If I were to rewrite this, if I write, I'm going to write here f of x, I'm going to replace it with y. Okay, we know that's really y, so I'm going to put y equals ln, and we know that natural log has a base of e, right? So we have this, right? Remember, this is just like a log. We can write this as an exponential. If we wanted to write this as an exponential, we can just shift a few things over, right? So if we were to shift a couple things over, we could have x equals e to the y, right? And this is going back to those equations we used when going from log to exponential, right? Well, knowing that, what happens if I replace the x here with 0? So if I replace the x with 0, right, well, what happens if you do that shift? Well, this x here becomes 0, okay? And this becomes impossible, okay? Nothing, so e to any power, okay, or a base to any power will never be 0, okay? It will never be 0. It's impossible, okay? So since it's impossible, okay, it's not part of the answer here. So that's why we have a vertical asymptote here, right? It's impossible. Same thing here. Think about this one. If you were to plug in a 4 here, right? If you were to replace this the x here with a 4, this would become 0. And the same thing would happen here, right? It wouldn't be part of it. It's impossible, hence why we have a vertical asymptote here at 4. Okay? All right. So let's go ahead and erase this, and let's talk about now the transformation that took place. Okay, so if I look at my parent function, I have ln of x. Okay, well, let's describe some of the transformations. The first one, remember, if I want to reflect something across the x-axis, I make the y value negative. So knowing that this is y here, okay, I'm going to replace this with y equals ln of x, okay? And then I said I want to reflect it across the x-axis, so I make the y negative here. So negative y equals ln of x. We can't leave it like that, so we divide by the negative. So our final answer here is y equals negative ln of x. So if we wanted to reflect this across the x-axis, this is what we would put in. Okay, and that's similar to what we have here. We do have a negative. So we know that a reflection about the x-axis took place. All right, so that's one of them. How about another? Again, going back to that table that I put up at the beginning of the video. Look what happens inside here. We have now a negative 4. That that's a horizontal shift, right? It's happening within the parentheses. So which way is that going? Is that going left or right? So remember, when you're dealing with horizontal shift, it's always opposite of what you're thinking. So if we have a -4 here, right, it really got shifted to the right, okay, 4. It's always opposite of what you think when you're dealing with horizontal shift. So this got shifted to the right 4, okay? So we can go ahead and write down those transformations. So we can say horizontal shift right 4, right? So it got shifted horizontally 4 spaces. And then we also said it got reflected about, so reflection about x axis, okay? And those are the 2 transformations that took place. All right, and that is it.